You're now recording. Awesome. So, ultimately these projects will likely end up in some level of a surface that has it has items that could be adjusted or changed, moved, rotated, opened, closed. It'll, form changing items in it. So what I would like to kind of go into is a plugin that you all should download if you haven't already. I know at least some of you have, because I've seen it in the scripts that I have looked at from you, and that is this Lunchbox plugin. So if you didn't know, Grasshopper has hundreds, if not thousands, of plugins that allow you that basically are just kind of bigger pieces of code narrowed down into one little bitty node that you could do it all yourself if you really wanted to, but it might take 20 nodes, and they've compacted it down into a single one, or they've actually written code in some regard, like a Python or like the Rhino code. I can't remember what it's called, and then distilled it into a node. So I would advise everybody to go download this Lunchbox plugin, because it has some very useful tools, and specifically these panelization tools, where you can create different kinds of panels. And there's even some attractor point stuff in there that you've done by hand, but they have some built-in nodes. So I would go download this. It will be useful, I promise. And the thing that we'll go through tonight, we'll use this to generate some of the surface that I'm going to create. So the goal of this is to kind of create a surface that has a triangular raised pattern that has some sort of opening that opens and closes in some way. There's 1,000 things you could do with that, other than what, we're going to kind of create a uniform surface, but obviously you could create surfaces that are related to an attractor point that are bigger. Triangles are bigger or smaller as they're closer and further away, or the openings open and close at different angles based on the sun or the wind or a sound or something like that. So the idea is just but what we'll create tonight is just a uniform surface, all the same size and shape, and they all open and close similarly. So that is our primary goal for this tutorial. So I'm going to just create, the only thing I'm going to put into Rhino, and I don't even technically need to put this in, but I'm going to just put a line that will be just to kind of shrink my code a little, but you could create this line in Rhino as well, or in Grasshopper as well. So with that line, I'm going to grab my curve node here. I'm going to set my curve to be this line, and I will extrude that curve as a surface in a direction of Z. And I will add a number slider to grow it and shrink it. Something I actually learned recently in Rhino, maybe, or in Grasshopper, maybe you all knew this, but if you want a number slider, if I double click and I type number slider, I can get a number slider that is a real numbers, or real number slider. It goes from 0 to 1. And I could obviously double click inside of this and change the specific version of Lunchbox that works best. I would say whatever the newest version is. I don't know if your classmates have a different feeling on that. What was I going to say? So the number slider, you could obviously double click inside of here, change it to an integer, and then adjust this to be 100. And then I have a number slider that's from 1 to 100. I can plug this into that vector and raise and lower that. Something that I learned recently is if I double click and I type 0, obviously the number slider pops right up automatically. And if I hit 2 dots and then I type 100, that will create a number slider that goes from 0 to 100 automatically without having to click inside of the number slider to change all those things. So just a little quick tip that I learned that I figured I'd share. So now I have a surface here, and I want to, now that I have the surface, I can use this to kind of create the panels and the triangular shapes that I want to use. So with Lunchbox, that's pretty simple. So if I go to Lunchbox, they have this panel tab, which has all kinds of different panels. And there's 2 different kinds of triangular panels. There's also, so you can see there's kind of like a hexagonal pattern of triangles, square, where there's a cross triangle inside of each square, and this one where it's just kind of the one. There's also random quad panel, skewed, all these different things you can use, hexagons, and all that fun stuff. So I'm going to just use let's use this triangular panel. And if I plug this in, I now have a triangular pattern on top of my surface, which is manipulatable. So you can see I have my U divisions and my V divisions. So if I was to do my little quick trick here and I say, oh, I want it to be a maximum of 30, I can plug that into here. I can create a separate one for the V, and I can make them more or less panels based on that. So more in the U direction, more in the V direction. And I can still adjust all this, and all these things are, adjustable. So that kind of creates our initial pattern, right? But what we want to do is we want to be able to kind of raise this, right? So what I'm looking to do in this tutorial is create a point. That's not what I want. I want to create a point in the center, and I want to kind of create a triangular pattern that's not on top of these triangles that raises that center point and creates, kind of depth to those triangles. So that's the goal we're shooting for here. And and then eventually we'll get to them opening and closing. So as you can see, I have, whoops, let me turn off my annotate. So I have my panels here. I'm just going to put a panel in here to see what I'm getting out of this. And this is important. This will become more important later on. So you can see that I have just a list of untrimmed surfaces, right? So 255 of them to be exact, which is all of these different triangles. We will come back to this because we will have to modify how these are coming out of this at some point. And we'll come back and we'll talk about that, but it's going to be based off of the fact that these are all currently in just a single list, a 0 list from 0 to 255. So we'll have to come back to that. So the first thing I'm going to do is I'm going to bring out all of the curves of this. So I'm going to drop a curve parameter in here, and I just want to grab all those curves. I don't want the panels, I just want the curves right now. So that's all of the lines that make up those triangles. So I now have that here. So you can see if I plug this in, I now have all the polyline curves that make up all of those triangles. So so like I said before, how I want to have a point that is in the center of this triangle that is elevated, that is in, extruded outwards. How does anyone have an idea of how I might find that point, or how I might get that point? Nobody? So what I'm going to do for now is I'm going to use the area node. And if I plug this geometry in, the area has a centroid, which gives me a center point in the middle of the area of this triangle. So I get all of the centers of all those triangles out of that. That is kind of my first step, right? So what I'm actually going to do, try to remember. Yeah, what I'm actually going to do to make this a little easier to see right away is I'm actually only going to work on one of these triangles at one time and kind of get that to where I want it to be, and then I'll kind of apply this to all of the triangles. It's just easier to see it happening in one spot than it is to see it happening in 255 spots. So what I'm actually going to do is, because this is a list of 256 items, I'm just going to grab the first item in this list. Does anybody remember how we grab a singular item out of a list? Nobody? Has anybody tried to grab anything out of a list?
You can use a number slider.
A number slider?
And there's more to it, but I kind of forget what else you need.
Sure. So all the lists related, items are in this sets tab here at the top. And if I click down here, you'll see all these different things, and all the things that relate to lists are in this top, well, all of these relate to lists, but the one I'm looking for is in this top bit. So what chat item, yeah, Earl is correct. So I want to get the list item because this whole thing from 0 to 255, this is all a list, but each of these is an item. And in this list, each of these numbers here is an index of the item. So this polycurve, this item, is at index 1, and this polycurve is at index 2. So if I was to plug this in to this category, this automatically defaults to index 0. So you can see now that I have that highlighted, I am just grabbing that singular triangle in this corner. So this is actually item 0. If I was to put a number slider here, oops, not what I wanted. And plug that into this index, I can move across, and I can see that that's actually item 2. If I can make this a little larger. Item 1 is that triangle right there. So obviously this goes 0, 1, 2, 3, 4, all the way across, and then up the chain all the way across the triangles. And you can see I can grab any single one of those all the way to the end. So I'm not going to plug anything into here because I don't need it to be a slider. I only want this one at the beginning. Eventually, so the only reason I'm doing this is I eventually will come back to this node here, and I will undo this, circumventing. I will plug this back in to get all of the triangles, but for the moment, I'm just going to mess with this singular triangle to get it to get this one the way I want, and then I'll come back and I'll apply it to all of them. So I can even, mark this here by making this a group. And if I wanted to be extra savvy, I could make sure that, I don't know, what do you want to call it? Reroute. Oh, this is rerouted or something. Rerouted. And I can come back and adjust this afterwards. So the first thing I'm going to do is or, you know, I have my center point, I have my centroid of this triangle, but I want each of these to be a separate, I don't want this to be a polyline. So right now, this is just a singular polyline, but I don't want it to be a polyline. I want each of these to be separate because I want to create a new triangle outside. Actually, we'll do that in a second. What the first thing I want to do is I want to be able to move this point outwards. So does anybody have an idea of how I might take this point, this center point, and move it in the y direction outwards from this plane?
Can you offset it?
Offset, I don't know if offset will work with a point actually. Let me see. Offset curve, surface, plane. Let me look at points. I don't believe that. I don't believe the point is gonna. I don't believe points offset. Maybe there's a way to do it, but there's another way to do it that I was thinking of. It's pretty simple.
Can you just do move?
Bam, nailed it. All you gotta do is move it. So I'm gonna click the move button, or get the move node, and I now have I have a geometry, which is my point. So my centroid gets plugged into the geometry node, or the geometry connector, and then the motion requires a vector. So so you can see right here, it's already moving it in the z dimension, because you see when I hover over this, it says 0, 0, 10. So default is it's going to move it 10 units in the z vector. So what do I need to plug into this motion to get it to move outwards? Any ideas?
The y vector?
Bam, y vector. So we want to move it in the y direction. So if I plug it into here, you'll see that I now am moving it in the y direction. And if I add a number slider, let's say we'll make it won't move out that far. We'll only move it out 5 potentially. And I plug this in, you'll see that it's moving, but it's moving in the opposite direction that I want it to move. So it's moving backwards. I want it to go this direction. So there's an easy way to do it for this surface, because this surface is just a plane. As this surface changes eventually, you need to do it in other ways to make sure that it's always moving in a specific direction. But for for our purposes right now, we can do it pretty simply. So there's at least 2 or 3 ways that I can think of to do that. One is there is a reverse vector. So if I was to plug this in here and plug this in there, you'll see that it reverses to the other side and moves out that direction. That's one way to do it. You could also use a math command and take multiply the vector, and if I come into my item, I can make this -1 commit changes, and I can plug that into here, and it'll move in the other direction. And then if we really want to kind of another way to do it, the third way to do it, is if I right click on top of this motion, you see I have these different options here. Some of these we've talked about, but not all of them yet. We'll talk about Graft a little bit tonight, but we'll talk about expression right now. Is I can actually type in an expression here. So if I was to type in -x into this expression editor and hit commit, it'll automatically flip basically whatever value is coming into here, kind of makes that a negative, and I can move it in that x, or in the other direction, in the y direction. I'm just going to make this a real number. Looks like we have a chat. Yeah, I just okay. So you can see that I moved now that way. So there's 3 different ways. There's probably 4 or 5 other ones if you really wanted to go deep into that, but we'll keep that as an expression for now. And we see that we have our point moving out in this direction. So we got our point out there. So now what we want to do is we want to create a kind of a triangulated surface on top of this. So what we're shooting for is, again, so this is my outside point. I want to create a plane, a surface that is like this, one that comes out like that, and then one that comes out like that. So this is the outermost point that is pushed out from the from this surface. So the next thing I need to do, the problem I currently have with that is when coming out of here is a polyline. So there's a few different ways we could do this, but what I want to be able to create a surface. So I want to be able to draw a triangle that has this as the base, then it comes up to here and down to here. So I want to draw a new triangle. So I'm going to take this this curve coming out of this polyline coming out of this node right here, and I want to explode that curve. So there's an explode curve command. If I take this and plug it into here, oops, not that. And I was to get the first item in this list, you'll see that I now have the a single line, coming out of this. Let me plug a panel into here, you'll see that I have a single line curve that is this line here. But I actually want to have all of them, right? So I want to have this line and this line and this line. So what I can do, if I zoom in real close here, you'll see they have these plus and minuses on here. If I hit the plus sign at the bottom, you see that I grab that second curve. And if I was to plug this in here as well, I would see that I have 2 curves. I have the first one and the second one. And if I go to the third one, I can get all 3 curves, and each of them has their own connector coming out of this list, right? So now I know that which is the first item, is this this line 1, the first item is this, and the second item is that. So now I can use those lines later on to create the new lines or the new surfaces. I can also, grab the points. So if I bring this down, disconnect. So if I grab here, you can see, maybe minus this. I have my first point. I can get my second point, and then I can get my third point. So I now know where my points are in here, because I need these points to be my start points for my new triangles to draw lines to create my new surfaces. So if I plug all these in, you'll see that I have all of these points now picked out. So I'm basically taking this list of items, because if I pop this over here, this is all of the curves, right? But they're all in a list, and I need to be able to grab them all separately. So this node here allows me to grab them all separately. Does that kind of make sense? Lists are probably one of the more difficult things to understand in Grasshopper, and they're going to become very important to you probably here in a few days' time. Trust me, you'll have questions when you get into the lists. So now the next step I want to do is I want to be able to create a triangle, right? So I want to be able to, oops, did I stop sharing? Oops, that's my fault. Let me do that again. Share back here. So I want to be able to draw a new triangle that uses those points as a those points as its start and end point. So how would I go about creating that new surface, that new triangle, now that I have these points?
Would you connect the individual lines, or is there like a more
Connect the individual.
efficient way to do that?
There's, I'm not going to lie, there are people who are way better at Grasshopper than I and any of us will ever be. So there might be a more efficient way to do it than the way I'm about to do it. But Gabriella's drawing something.
Yeah, I messed up. That's not what I was intending. But I think you can like connect those two that I kind of came from with a line thing.
Exactly. Yes. So a line thing. We will create a new curve, a new line between 2 points. So it's I'm going to delete these panels for now. I have my start points, or I have all my start points. I have my end point, or well, some of them are starts, some of them are ends. So I can draw a line from here to here, right? So if I was to, problem is now I forgot which one's which, so we'll see what happens when I connect these two together. So my start to end, that was perfect. So from that point here to this point there, I've now created a line that connects those two, right? I can copy this. I can keep my elevated point the same, and I can plug in a new line here, and I now have these two lines. I already have, if I was to grab the curve tool, I think it's this one. Nope. That's not what I wanted. I already forgot. Let me see which one's which. So this one is the bottom. Okay, so bottom is that this one is 1. That one's, or that's what this one's 0. That one's 1. This one's 2. Okay, so I can then, this I represents this bottom curve, this bottom line. So if I was to join these curves together, I can plug using shift. I can plug all of these into this line, and I now have a triangle, right? That I can create a surface out of by using this boundary surface. I can plug those into here. And I now have, let me hide this. Let me hide this. So I now have a surface that's coming out and touching that face. And if I was to adjust the depth, that triangle moves with it, right? That surface moves with it. So all I need to do is repeat what I just did and create the other lines, right? So actually, I'm just going to start from fresh. Too much of a pain. So I want 2 more of these. I want to grab this one, which is 1. So I'm going to put 1 in there. I'm going to actually, I could actually reuse this line, so I don't need to recreate that line. I really only need the 1 line for this, which should be 2 to here. And I can use the join curves command, and I can unplug that and unplug this. So I want this line, which is that one. I want this line into here, and then I want number 2, I believe, in this. Oops, I did it. Number 2 into, come on, bro. Number 1, sorry. This here, this here. There we go. So now I have my second triangle, which I can copy this down and I plug this triangle into there. I can do it one more time. With one more line command. Actually, I don't need that. I have these two. I have that. So I can just join curves. I'm gonna unplug these for a second. I don't do well with looking at the wires plugging all in. So I want that line. I want this line, hold down shift. And I want this line here to create my triangle, which is correct. I can create a new surface like so. Plug that into here. And now I have a new shape that should adjust with the, where are you? This one right here. I can move that in and out and adjust that shape to be, you know, deeper or shallower. I'm just going to group that so I can find it again. Scribble. Any questions on that? So now is the part where if you thought, oh, okay, I did it. Got the one triangle. Awesome. Now all I need to do is come back here where I had my singular triangle picked out. In theory, all I should need to do is take this node and plug this node into into here. Whoops. From here into here, and from here into here, and then, you know, kind of circumvent that node, and everything would be fine. But let me just save as for a second because there's a non-zero chance that it could crash. So if I was to do that, I took this, I plugged it into here. Some craziness starts to happen. I take this, I plug it into here. And Rhino's going to take a second. You'll see that it's not exactly, if it ever, you gonna make it? Yes, barely. You can sort of kind of tell that it's not what we're looking for. You can't really zoom around right now because there's so many lines being drawn. Does anybody have an idea as to why this isn't just working the way we want it to work? I'm going to unplug this first, or actually I'll leave it like that. If I can move, yeah. So it is related to the, let me put a panel here. It is related to this list, right? The problem that's happening is I have this singular list of 255 items, and when I run that, when I pull out that singular list or that singular triangle, it works fine because I have one set of curves that I'm operating off of. But when I have all of them and I get to these list items, I can probably see it going awry here. I'm not grabbing the right stuff. So it is the right, basically because I'm filtering these lists and I'm trying to grab singular items in them, because this is all one list, it works when it's a singular item. But if I was to, let me put a panel here, actually, maybe this would be better. You can see that I have the way that the lines are coming out in these lists is not going to work because it's basically drawing lines between all the different points. It doesn't know where it's not filtering the triangles down in the right way. This is really hard to explain, so I apologize. So this is where Graft comes into play. So if I right click on this at the panel connector, there are these items here: reverse, flatten, graft, and simplify. Reverse just reverses the list. So if I clicked reverse, it would, whatever the last item is, makes it the first item, whatever the first item is, makes it the last one, and so on and so forth. Flatten, if I flatten this list, nothing would happen. This is an already flattened list. It's a singular list with 255 items in it. So nothing would actually happen. You could flatten it, but nothing would change. If I graft this list, what it basically does is it takes this single list of 255 items, and it makes 255 lists with a single item in it. So if I was to right click and click graft, you'll see that automatically after I did that, it fixed itself. So it's grabbed, it's made 255 lists with a single item in it. And then these lines, even though it's still 3 lines, it's 3 lines from the right list, if that makes any sense. So if I was to, let me make another item index and subtract this. So you can see how when I click on this list here, or these segments. Let me get a panel in here. So I am when I put a list here and I grab this and I grab the 0 item. Now, what I'm grabbing is the 0 item in every one of these lists. In all 255 items, I'm grabbing the 0 line. So you can see here, I have 255 lists, or 255 with a single line in it. So what I'm grabbing is just this one line of all of these triangles. And let me save again, and I'll ungraft it, and we'll see what we grab. Hopefully it doesn't crash. So I'm gonna right click, I'm gonna click graft again. It's gonna take a second. It's basically taking all of those triangles and putting them in their own list. So when I explode their lines stay in that same list. And it's going to be hard to understand, and sometimes it'll feel like, oh, I just clicked graft and it worked. But just know that when that happens, it's because you're reorganizing those lists, right? So when I grab this now, you'll see that I'm grabbing a bunch of other lines. It's hard to see. Let me hide everything. Let me preview this. So you'll see that I'm getting other lines. I'm getting the lines that I kind of want, but I'm also getting some other lines in there that are not exactly the ones that I want. But which is what's causing those problems, because now I'm starting to draw lines to points that I don't want to be drawing lines to, whenever it gets filtered down the list even further. And if I go back to grafting it, actually it looks similar. Boop, boop. Maybe it's filtering it differently than I thought. Let me turn this back on. Okay, so I'm not sure why it looks similar. I am still grabbing those lines. That's interesting. Oh, that's that line. Okay, I'm not maybe I need to understand a little bit more on how this specific graph is working when you graft it. But you know, the graft is needed at this point after here to get this list filtered down into those 255 lists, right? So now if I was to change these things, like I said before, all of this is still parametric. I can adjust all these things, all the triangles adjust. I can add more, I can add less. I can make them short and squat, make them more square. I can adjust their depth in and out. From here, I can adjust their depth, make them deeper or shallower. All's well with the world. I have a nice surface, and if I was to come over here and bake all of these like so, I could grab I'll do that. I can grab these, I can move them over, and you can see, oops, I didn't grab all of them. Hope I didn't bake all of them, that's the problem. So I could, if I really wanted to, I could join these together into a singular surface that I could then bake like such. And it'll make basically each of those triangles its own shape. I can come in here, I can grab these like so. Get this in, whoops, not what I wanted. I now have a surface that, you know, this triangulated surface, right? So now we want to take it one step further. So we want to start to manipulate the opening, the way these triangles, we want to create openings. We want them to kind of open up and create. So I want these to rotate in, I want these to rotate in this direction. I want this one to rotate in that direction. I want this one to rotate in this direction so that I can create openings in between all of the different triangles. Does anybody have any ideas how we might do that?
Are we able to just rotate like the parent set of panels?
Rotate the parent set of panels.
Does that make sense? Like just the one triangle and it'll affect all the other ones?
Exactly. Well, it's not really a parent. Like this one, they're all individual now, technically.
Right.
But I can rotate. So you can see when I select this surface, this is all of those, you know, one side of that triangle. This is all of the other side of the triangles, and this is all the third side of the triangle. So we can rotate all of those separately, if that's what you mean.
Yeah.
Yeah. Okay. So yes, we can rotate. So it's just as simple as rotate, right? I want to rotate around an axis, and now I have this rotate command. This is my geometry. I can plug in my geometry, but you can see that it's rotating all of those triangles in a weird direction automatically, because you can see that the axis is a line, you know, an arbitrary line that's drawn. So the axis that I want to grab, so first I need to plug in the angle, right? So I don't want to rotate them that much. So let's say I want to rotate them up to 45 degrees. I need to convert those from degrees to radians. So I can plug it in here. I can plug that in there. If I do 0, nothing happens. And if I rotate them like this, you can see that they're rotating around a line, some arbitrary line that is 10 feet. I'm not exactly sure where that line is. So what I want to do is I want to define that axis. So does anybody know where I can grab the axis so that it rotates in the right direction? We already have it. So we have these lines, which rotate, which I can grab to rotate the axis. So what I want to do is grab this line here. So I want to find where that line is in my series of lines and use that as my axis. So it's not any of those. It is one of these. Question is, I can't remember which one. So I think it was, look down here. I think it was the first one. So if I go and I grab, use those lines, I believe it's this I can plug that into the axis, and you can see now, if I go back and hide all this, I've grabbed those triangles, and if I grab this here, I am now rotating them around that axis that I picked. Super easy. So now all I need to do is do that same thing with the other ones and pick the right axis. Oops, it was right there. So I need to do that 2 more times. So I'm going to unhide. I'm going to preview this again so I can see where those are. I'm going to not preview that. So I need to grab that second line now. So same thing, I can grab my surface, plug it in here. I can use the same angle, plug it in there. It's going to get all weird because it's going, like I said, going in the wrong direction. We can grab, and I believe it's this +1 here. See, like that. And hide the surface again, preview. So now I have 2 triangles rotating on the right axis. I can grab, do it one more time, like so, and then I can grab the last one here, which I believe is, yep, this one, like that. And now, if I go into the front view, oops, might be a little off. One of them might be off here. Okay, something's off. So let's go back to this and see which one's going the wrong way. So one of them, oh wait, I'm not showing it. It's not previewed. Preview. One of them looks like it's rotating the incorrect direction. So, oh, they're all rotating inwards instead of outwards. Okay, they're all going in instead of out. So I want to reverse this angle, I believe. So if I can use the same expression thing that I used before, see if that works the way I want and they go the right direction. So one of them's going, this one is going the right way. So if I just reverse all these angles, -x, commit, angle, expression, -x. You could also use the multiplication tool and go the negative direction, or multiply by -1. You can see when they're all closed, let me select off, I can open them up and create, them to be fully open or moderately open. I can change these however I want. And similarly, I can join brep. Oops, some kids outside. Plug these all into here. so that if I wanted to, I can bake this into the project here. I'll pick that. Move these over. Look at this. And I now have a surface that's starting to, be manipulated and create more or less opening. And I would hope that you can imagine that let me just delete this. That all of these things, I don't necessarily need a number slider here. This number could be different for all of these triangles based on the direction of the sun or the angles of the sun. The lower the sun gets, the smaller this angle starts to become. So this is just a number getting plugged into here, but you could modify them all individually using the data that you're about to, that you're starting to hopefully collect. And like I said before, all of these things are like everything. All of these things are manipulatable. I can add more triangles. I can make it taller. I can, add more in a certain direction. I can add less in another, like so. And I could adjust their depths to make them a little more dramatic. All this stuff is still adjustable, and you can start to make these things, iterate through multiple options, right? Like I said before, so this one is simpler because it's a flat plane. Does anybody want to know why that if we started doing this on a curved plane, we have, does anybody know what the problem would be, start to come out of this? If this was a different kind of surface, which I assume you guys will probably eventually have. What's the main thing that would start to cause us problems in our in this go ahead.
The rotating axis wouldn't be constant.
Rotating axis wouldn't be constant.
Or like uniform at least.
Uniform. I mean, it depends. It should still be. Well, I guess you're saying if it was a curved surface, that you can't. You're not rotating along a curve is going to cause us, them to be not connected in a flat way. Is that what you mean, Nick? Or did you have something else in mind?
Yeah, that's what I meant.
Yeah. So, so that would be one problem that we'd have to evaluate in this specific, the rotation one. Obviously there's other ways that you could get these openings. There's also another issue with the way this is being done, and it stems from, where is it? This node right here, the way that we're creating the depth. Does anybody know why, if this surface was a curved surface, why that would start to, this area right here would start to cause us problems? Specifically these two nodes. Well, really this node.
It would have to constantly be changing based on like the normal plane that you're kind of going around.
Exactly. Yeah. So if you have a curved surface, the Y direction might not be the way you want to extrude it, right? And that goes back to the term that we talked about, early on in the semester, which is the normal, right? We want to be able to, we would have to find the normal on a surface. So let me see if I can, we talked about this a little bit at the beginning. Let me create something real fast. Hopefully we can copy this back. So if I was to grab those curves, in here. Curve, I'm gonna set multiple curves. Grab this one and this one. I'll loft these two together like so. You know, if I wanted to do this same pattern, I'm not going to plug it in because it's probably going to crash my computer. But if I wanted to do this same type of thing, like Nick said, the rotation might get off because this is a curved surface. So, you know, rotating along, it's not going to rotate properly. So we have to find either a different pattern or a different way to create this opening. If that were the case, or this can't be a smooth curve like this, it'd have to be straight sections. One, and two, if we wanted to pull this triangle out, in this definition, we're just saying, oh, just move this point, move the point we created, which is the center of the triangle, move it out in the y direction, this dimension. But on this surface, the y direction is not the right direction, right? So the y direction is this way, which is not, we don't want to move the points that way. And on some parts of the surface on the top, it's like, so then you might say, well, oh, we'll just move it in the z direction. We want to move it that way. But for the triangle that's over here, we don't want to move it up that way. We actually want to move it out this way. So all of these, every single triangle on this surface has a different up, right? So that's when we need to find the normal of a surface. So let's see if we could, you know, the fastest way to do that, there's an evaluate surface command here. And then I can get a slider here. And then I want to, so here's a, I don't think this will work exactly that way. Yeah. So this is here's another definition of one of those terms. So sometimes you'll see different terms in here, and one of them is Re-Parameterize. So right now, what I just created was I created a surface from two curves. I got the curves, I lofted them, I threw them into this evaluate surface, which gives us a bunch of different things that we can pull out of it. And then I use this is called an MD slider. MD slider, is that right? Yeah, MD slider, which is a multi-dimensional slider, which kind of gives us, it allows us to go, to move in two directions, you know, simultaneously. But you can see that I'm moving, but I'm moving in a very small spot down here in this corner, which isn't what we want to do. I think if I double click on this, I can change this. And, you know, if I knew the exact size of this surface, I could type it in and I can make sure that it met the whole thing. But what I can do, another thing I can do is I can re-parameterize this surface. So that way it kind of reevaluates, it basically makes this surface, it kind of converts it back to that UV value, right? So I think if I right click on curves and I click re-parameterize, or maybe I have to re-parameterize, oh, I'm sorry, that was wrong spot. Let me undo that. If I click on this surface and I re-parameterize, you'll see that curve, that point just moved over. I'll do that again. So it's here right now at this point, which is, you know, 1 foot by 1 foot or 1 inch by 1 inch square that it's moving in. If I re-parameterize this surface, it's going to jump to a different location. And now it's wherever I want. So 1, 1 is that back corner. 0, 0 is this one. If I stay along here, I can go along that line and I can move along this way. So now that I've re-parameterized it, it basically has made that point 1, this point 0, and it's redone the surface, reevaluated the surface, so that way I can use this more easily. So anyway, back to this. If I had this surface, I would have to use this evaluate surface command. And if I created a line and that start of that line was from that point, or that the point is here, the normal is the direction. and I'll make it 5 long. You now see that I have a line that is exactly quote unquote normal to that point. So directly quote unquote up. It's going the incorrect direction. So I can probably reverse this direction. Oh, that's not what I wanted to do. I can expression negative x and push it outward. So now it's going up. And if I was to move this line or if I was to move this point, that line is always staying directly upwards. So if I was to redo this surface and I needed to find out what up was, I couldn't just plug this vector in. I'd have to evaluate the surface, and this normal is a vector at a specific point on that surface. So I'd basically have to, grab the surface. The point that I want to move is the centroid from this, from here. That would go into the point category, and then I would pull the normal, which would be the vector it wants to go out that way. So when you get to these more complex surfaces, you have to, it's not as simple as I want to move it in the y direction. So you'll have to, figure some of that stuff out whenever you're getting your surfaces made. So that was a little maybe dense for some people, maybe not. Was there any questions any questions based on this or thoughts or concerns about it? So, this is just something, this is just one way to do this. You could probably find I know you can find 1,000 tutorials on different kinds of surfaces you can create. You can use different kinds of panels. You don't have to rotate them. You could do something different. You could shrink them. You could create some, you could start to, maybe I don't want them to be triangles like this. Maybe I want to modify the shape. I want to fillet some of this, or I want, I want perforations in there or something. There's 1,000 different ways that you can start modifying this, but this will kind of this something like this, a flat surface like this with that I just created might be your first proof of concept of your thoughts, of your inputs and outputs, which is what you'll be working on over the weekend to next week, hopefully, as long as we can get everybody to a point where they're comfortable with their concepts. So any questions, concerns on that before I stop recording? Any questions about normals and or anything I did over here? This will become, like I said, this will become important when you start to kind of make more complex shapes other than a flat plane. Nothing? So everyone understands lists. They know everything there is to know. I'm sure you'll run into some brick walls when you start playing with your stuff. So we will figure it out. All right. So if there's nothing there, then I'm going to stop recording. Make sure there's no chat stuff. Doesn't look like it. So I'm going to stop recording.